In this video, we're going to try and develop a way of describing a line in 3D space. So let's say you've got a point here where it's 2, so this is the origin, 2 across, 1 across in the y direction, and then 5 up. Let's just say this is 5, and then you've got another point here, 4 across in the x direction, 1, 2, 3, 4. 4 across in the y direction, 1, 2, 3, 4, and 10 up. Let's just say 10 takes you up to here. So you've got a you've got 2 points here floating in 3D space. So with 2 points you can always create a line. Well, this line here you can always think of it as being a vector. There's a vector that takes you from this point to this point. So with 2 points floating in space, in 3D space, you can always create yourself a line. So in this video we're going to develop a way of describing this line. So you've got 2 points floating in 3D space. That means you can extract the vector from here to here. You can extract that vector by getting this, taking away this. So it means that from here you would need to travel 2 across in the x direction. So it's 1, 2, and then this take away this, that will be 3, and then 3 across in the y direction, 1, 2, 3. And then this take away this, that would then give you 5. So 5 up in the y direction. So that would take you from here to here. So this vector here represents the path from here to here. So now to describe anywhere on that line, we could do this. Hang on. So you've got yourself. So this is your vector here. This is your vector here. So if you want to describe, let's say this point here, if you want to describe, let's say this point here, you would say, well, start at this position, and then, well, we've got a vector here. 3 times. So you would start with your well, think of this as being a position. This is our position here. Think of this here as being a position, a location somewhere in 3D space. So this thing here is like starts at this location here, and then if you want to describe this point here, then times the vector by 3. So insert the 3 into the t. So this t, we would introduce this t here. This t here is a scalar quantity. So if you want to describe this point, then 3 times our vector. So to describe this point, we would start out at this location here, and then stick a 3 into this t here. So this is our vector here. So 3 times our vector would be 1, 2, 3. That will then take us to here. If you want to describe this location here, right here, then maybe stick a 1.7 into here, into the t. So start with this location. So you would insert this location into here, and then this is our vector here. That's this vector here. Well, times that by 1.7. Well, times 1 would take you to here. Times 1 would take you to here. Times 2 would take you to here. Well, you want slightly less than 2, so times 1.7. That would then take you to here. If you want to describe this location here, let's say this location, so you would need to go backwards by 2 steps. Let's say 2 steps. So you would need to insert a -2 into here, into here. So you would need a reference point. This is your. You could use this point, by the way, and start here if you want to. But let's just choose this point here. Insert this into here. And then if you stick a -2 into here, it will go backwards in this direction. 1, 2. So you would be describing this location. There are lots of other ways of describing a line in 3D space. We will look at them later on.